In these videos, we'll be looking at Stamp 6, problems 5, 6, 11 through 15, instead of 11 to 13, 26, 30, and 57. Alright, so problem number 5, we start and for 5 and 6, we need to 1, find the LCD, 2, multiply each term by the LCD. Alright, doing that will allow us to eliminate our fraction. Alright, we won't have a fraction left. And then last step is to solve what we have remaining. Alright, so those are our steps. Let's see what we can do. Alright, the problem, 3x over x minus 1 is equal to 12 over x squared minus 1 plus 2. And let's just write that as 2 over 1 so we can have all fractions. Alright, first things first, look at your denominators and try to factor these. Alright, and you got one that needs to be factored. It's a difference of 2 squares. So that becomes 3x over x minus 1 is equal to 12 over x minus 1, x plus 1. Alright. Alright, plus 2 over 1. So now we can see what the LCD is for this problem. And the LCD is x plus 1, x minus 1. Alright. Take our LCD, multiply each term by that. Alright, in this case, we got x plus 1, x minus 1. Alright, we're x plus 1, x minus 1 again. And x plus 1, x minus 1. So, from here we cancel what we can cancel. Alright, the x minus 1's cancel for the first term. Alright, we're left with 3x times x plus 1. For the second term we have in this equation, alright, everything cancels. So we have 2. And for the third one, nothing cancels. Alright, and so we can go back to the fact that this is x squared minus 1. Alright, and so we are going to, oh, I'm sorry, this is a 12. I missed that 12. Alright, plus 2 times x squared minus 1. Alright, now that we have that line, let's see if we can solve what's going on here. Alright, first things first, let's do some distributive property. Alright, that's 3x squared plus 3x equals 12 plus 2x squared minus 2. Alright, now from here, let's simplify this a little bit, because from here we're on step 3 and we're solving. Alright, we have 3x squared plus 3x is equal to 2x squared, and we want to combine our like terms, and that's a plus 10. Alright, from here, since we have our highest exponent is 2, we want to move everything to one side. Alright, we're going to start by subtracting 2x squared from both sides. Alright, if we do that, we end up with x squared. Alright, plus 3x, and then we want to also subtract 10 from both sides. Alright, and if we're careful, alright, we get minus 10 is equal to 0. Alright, now from here, let's see, it looks like we need to factor. Alright, so we're looking for two numbers to give us a product of 10 and a sum of 3. That would be x plus 5, x minus 2 equals 0. From here, 0 product rule. X plus 5 is equal to 0, or x minus 2 is equal to 0. Subtracting 5 from both sides gives us x is equal to -5. And adding 2 to both sides will give us x is equal to 2. All right. Going back and checking your answers, and usually for these problems, not saying that we shouldn't check our answers, but we really want to make sure if we plug our answers into our denominators, all right, we want to make sure that we don't end up with a 0 in there. All right, and I think we're okay. You can fully check your answers, and I'm pretty sure both answers work for this problem, and they do. All right, number 6. All right, we have x over x minus 2 plus 3x over x minus 4 is equal to 32 minus 2x over x squared minus 6x plus 8. So right away, for the problems we've done in this, similar to this, usually this trinomial, when we factor it, these other two denominators become those factors. So I would start by checking to see if that's true for this problem. Multiplying gives us 8, adding those give us -6. So yes, that is those are our factors for this problem. All right, now that just means that it's easy to find our LCD for this problem. All right, our LCD is x minus 4, x minus 2. So we're going to multiply each term by that. All right, x minus 4, x minus 2. All right, x minus 4, x minus 2, and again. All right, now from here we want to cancel. All right, and everything cancels on that left side. We are left with 32 minus 2x. All right, here the x minus 4 factor cancels, and we're left with 3x times x minus 2, and the x minus 2's cancel here, and we have x times x minus 4. All right, so from here, we can back to distributive property a little bit. All right, distributive property gives us x squared minus 4x plus 3x squared minus 6x, and that's equal to 32 minus 2x. All right, so got a little bit of work to do. We need to combine like terms on this left side. Looks like we end up with a 4x squared minus 10x is equal to 32 minus 2x. All right, from here we want to move everything to one side again. All right, good thing we got some evens here, which should work out okay with us. All right, we're adding 2x to both sides. That's 4x squared plus 8x. All right, we are also subtracting 32 from both sides. All right, so that's minus 32 equals 0. All right, from here, all right, we want to divide out a 4. We can divide a 4 out of every term. All right, that'll give us 4 times x squared plus 2x minus 8 is equal to 0. All right, now factoring what's in the parentheses, we're looking for two numbers to give us a product of -8 and a sum of 2. Those two numbers are x plus 4 and x minus 2. All right, now from here, zero product rule. All right, 4 is never equal to 0. All right, we have x plus 4 is equal to 0, which means x is going to be equal to -4. All right, or x minus 2 is equal to 0, which means we have x is equal to 2. All right, so these are the answers that we end up with, and now we need to check them. So if we plug them, well, if we plug those back into your denominators, all right, your original denominator, you will see that 2 will give you an invalid, it will give you a 0 as a denominator. So because of that, 2 is an extraneous solution. All right, 2 is automatically an extraneous solution. All right, once again, because 2, if we plug it back into that first denominator, all right, we get a 0 as a denominator, and we can't have that. All right, if we plug -4 in, we're okay. All right, and that's really what we need to check for. So our real answer is x is equal to -4, and we have an extraneous solution also. All right, and our extraneous solution is 2. All right, and as I look at the problem, the answer in the book, it's a little bit different. So I'm gonna go with my answer, and we'll see from there. Question number 11 says, which is equivalent to log of 20 over log of 2? All right, so in this case, what they're trying to get you to think about is change of base. All right, and change of base for log 20 over log 2 would be, remember the base is always in the basement, we go log base 2 of 20. All right, and in that case, the answer is C. Number 12. All right, they say evaluate. All right, and so we have log base 7 of 6,904. All right, it is a calculator problem, so I'm assuming that they want you to use again change of base. All right, remember the base goes in the basement, 6,904, or you could go natural log. Either way. All right, 6,904 over natural log of 7. All right, either way works. All right, and in that case, our answer for number 12 is 4.543. All right, for number 12, knocking them out. I'm sorry, 13. All right, once again, same type of problem. All right, log base 4 of 0.0123. All right, in this case, let's say we can go natural log of 0.0123 over natural log 4. Could I do log? Yes, I could do log over a log. That's fine. Either way is okay. All right, and in that case, we end up with -3.173 if we do that in the calculator. It's a calculator problem. All right, for number 14 and 15, everything above that line are notes, all right, that are going to help us with the problem, things that we need to remember. All right, when we're doing translations, transformations, A reflects about the x-axis when negative. A also vertically stretches when A is greater than 1, all right, or actually outside of -1 to 1. All right, and shrinks when it's smaller. All right, when the absolute value of it is less than 1. All right, R which is kind of new for this year, reflects it about the y-axis. So in other words, it takes the graph and flips it this way. All right, so if you had a graph that kind of looked like this, it's going to flip it with respect to the y-axis. All right, and so it's just going to flip it across the y-axis versus flipping it across the x-axis. All right, it also vertically shrinks and stretches, and you notice I did this opposite because when the absolute value is greater for r, when it's greater than 1, then it shrinks. All right, and when the absolute value of r is less than 1, it actually stretches. So it works opposite of a. All right. Also, our h is our horizontal shift, left and right. All right, and our k is a up-down shift. All right. So for number 14, your starting equation is f of x is equal to 3 to the x. And they're asking us to find g of x. We're going to reflect it about the x-axis. That's that a will be negative. All right, a will be negative. All right, and then translate the graph left 5 units. All right, left 5 units would mean that h would right here, h is equal to -5, but when we put it in the equation, it changes. All right, so for this problem, g of x is going to be equal to a -3, because our base is 3, so we start with the same base. All right, and that's what the b stands for, our base. All right, 3 to the x. Now, when we put h into the equation, just like sinusoids and everything else we've done this year, all right, it becomes the opposite. So, or a -5 becomes a +5, and we're done with that one. All right. For the next problem, it's reflected about the y-axis. So in this case, r is going to be negative. All right, and then it stretches vertically. All right, so our vertical stretch is stretching our a value, and so we're going to say that a will be equal to 7. All right, so if we do that, all right, we have g of x is equal to, well, let's just put the 9 there. All right, we're going to go put a parentheses here. We're going to go 7 times 9 to the -x. All right. And I think that's it. Number 26. A population that grows continuously. So continuous population is that shampoo formula. A is equal to P times E to the RT. Has an initial value of 400. So initial value of 400, E. All right, got the E there. All right, remember the E is a constant. After T equals 8 years, so let's put the 8 in. The population should be 1,000. All right, and you have the R. It says, what is the continuous growth rate? So we're looking for R. All right. Your answer should be correct at 3 decimal places after the decimal point, or to the nearest 1/10 of a percent. All right, so we're solving for R. Let's start by dividing both sides by 400. All right, this gives you 5/2 or 2.5. All right, it's equal to, this cancels, E to the 8R. Now that I have that, all right, if I want to continue to solve, all right, I have an E here, so I want to natural log both sides, all right, in order to solve. Our natural log E cancels, that is 8R on that side. This side we have natural log of 2.5, and then we want to divide both sides by 8. So R should equal the natural log of 2.5, make sure you close your parentheses, divided by 8. All right, and if we do that correctly, all right, we should end up with an R value. All right, an R value of 0.11. It says 45, so we're going to go 0.5. Or it said write it in a nearest tenth of a percent. It would be 11.5% is another appropriate answer for that question. All right, problem number 30. All right, the percentage of adult height obtained by a boy X years old is modeled by the function f of x is equal to 29 plus 49 log of x plus 1. So, thing that you need to know is that x is the years. All right, x is the years. All right, is the age of the boy. All right. So it says in A, it says approximately what percentage of his adult height is 9 years old. So take the 9, f of 9 is equal to 29 plus 49 log 9 plus 1. All right. This is a no calculator problem, so let's see if we can get it. 29 plus 49 log 10. So remember, this is always a 10. So what is this equal to? 1. All right, that's 29 plus 49. Since this is 1, this is equal to 1. All right, and so that is 78%. 78% for number 30. All right, letter B. They're asking us at what age, correct to 3 decimal places, will a boy reach 90% of his adult height? So remember, this f of x is the percentage. So we want to plug 90 equals 29 plus 49 log of x plus 1. All right, and it's saying no calculator, so let's see if we can do it without the calculator. All right, I want to subtract 29 from both sides. All right, that gives me what? 61. Sorry, is equal to 49 log x plus 1. All right, remember this is always a base 10 if it's log. All right, we want to divide both sides by 49. If we do that, we end up with 61 over 49 is equal to log of x plus 1. All right, I want to get rid of the log, so we want to go base 10. Base 10, we want to raise it up to a 10. Raise it up. All right, that will give me 10 to the 61 over 49 is equal to x plus 1. All right, and from here we want to subtract 1 from both sides. So we're saying that x is going to be equal to, let's see, 10 to the 61 over 49 minus 1. And so I honestly don't know how you would do this without a calculator, unless they're saying that A is the non-calculator problem. Yes, that's what they're saying. So at this point, you can plug all this in your calculator. If we plug it into our calculator, we should end up with approximately 16.575 years. All right, so done. All right, last but certainly not least, number 57. All right, very straightforward problem, no calculator problem. So let's take this calculator, move it out of the way. All right, it says what is the distance from point 2 comma negative 3 and the line whose equation is 3x minus 4y plus 12. All right, so just taking out the information that you need for the problem, your x and your y is 2, negative 3. All right, your a is 3, b is -4 and C is 12. All right, so finding the answers for these should be pretty straightforward. All right, we're plugging into this formula on the front, distance of a point. They give you the formula. All right, all you got to do is plug in for this problem. All right, and plug in appropriately. All right, so we have the absolute value of 3 times 2 plus a -4 times a -3 plus your 12 all over the square root of your A value, which is 3 squared, over -4 squared, or plus -4 squared. All right, so that's everything plugged into the problem. All right, let's simplify that. All right, if we simplify that, we end up with, let's put it here. Can we see that? Yep. All right, if we simplify that, we have the absolute value of 6 plus 12 all over, well, think about this for a second. This is 9 plus 16, so it's the square root of 25. All right, 12 and 12 is 24, plus 6 is 30 over 5, which is equal to 6. All right, so our distance is 6 units. The end.